day, young scientist. It's a brand new day again here in my science class, and I'm Sir Paulo A. Rivera, your science teacher for today. I'm so excited that you are with me to learn new concepts, skills, and competencies in science. Make sure that you are in a comfortable place so that you understand and you hear me loud and clear. Let's start! The objectives of our discussion for this morning, what you need to do is to number 1, define what is work. Number 2, familiarize on how work was done. And number 3, solve for the value of work. And now, what comes first when you hear the word work? It has a lot of meaning, but when you ask, where do you work? It always refers to a particular job. And when I ask you, as your teacher, have you finished your homework? It is referred to the task that I given to you. In physics, work is an idea that is related to an energy, wherein work is done by an object, its energy loses. And when work is done on an object, it gains an energy. In our previous discussion, we talked about that force is simply defined as a push or a pull, wherein when an object is pressed, it can be moved by an exerting force. And when the object is moving, it can be slowed down or stopped by the applied force on it. In science, work is done when the object you applied force is moved on a distance in the direction of the motion towards which you are pushing it. And no work is done when if you exert force but the object does not move. Basically, work in physics, it measures of energy transfer that occurs when an object is forced over a distance by an external force, at least part of which is applied in the direction of the displacement. In other words, as the product of the net force acting on a body and the distance moved in the direction of the force. And always remember that the symbol for work is a capital W. And to solve for the value of work, what you need to do is to follow this formula. W is equals to F and D. Or simply, W is equals to the product of force and displacement. And to be familiarized with different letters on our word formula, first, for the capital W, that is work, wherein it is always expressed in Nm or in Newton meter or in a capital letter J or the value of joules, wherein letter F stands for force, that is always expressed in capital letter N or in Newton. And for letter D, that is the value of our displacement, that is always expressed in simple or small letter N. And do you have an idea where come first the idea of joules was from? Very good. Joules was named after the famous English scientist James Prescott Joule, wherein it is also a unit for the value of energy, wherein for every 1 joule, that is equivalent to 1 Newton meter. And now, since we have the idea about the formula and the basic concept of what we called as work, now let's try to apply this work formula in a work sample problem. Let's start. For problem number 1, a force of 15 Newton is used to push a box along the floor a distance of 3 meters. How much work was done? Now, for you to be able to solve for the value of work, what you need to do is to follow the step-by-step process. So, the first process that we need to know is to get all the given value on our sample problem. So, since we have now the problem, so now let's all get the given value. First, since the problem has a 15 Newton, this would be our force. V is equals to 3m or 3 meters and W is equals to question mark, or this would be our unknown value for this sample problem. And after we get all the given values, now let's proceed with the correct formula. Now, the formula for the value of work is W is equals to F and E, or W is equals to force multiplied by the displacement. After we get the formula, now let's substitute all the given value. So W is equals to 15 Newton multiplied by 3 meters. Then W, or work, is equals to 45 Newton meter, or it's simply as work is equals to 45 joules. Alright, so now let's proceed with sample problem number 2. Eleazar weighs 82 Newton and climbs a flight of stairs 6 meters high. How much work does he do in climbing the stairs? Again, what we need to do is to get first all the given value on our sample problem. For problem number 1, 82 Newton is our force. Displacement is equals to 6 meters. And again, the missing value here on our sample problem number 2 is the value of work. Now, after we get all the given value, now let's proceed with the correct formula. The correct formula here is W is equals to force D, or force multiplied by the displacement. W is equals to 82 Newton multiplied by 6 meters. After we substitute the given value, let's proceed with the W is equals to 492 Newton meter, or work is equals to 492 joules. And now, for our sample number 3, so what you need to do is to practice. Now, for problem number 3, suppose a woman is pushing a grocery cart with a 500 Newton force along 7 meter side aisle. How much work is done in pushing the cart from one end to the aisle to the another? So I will give you a 1 minute to answer this sample problem number 2. Are you ready? So let's try and let's begin. Time's up. The time is over for our sample problem number 3. Now, let's answer the sample problem number 3. For sample problem number 3, suppose a woman is pushing a grocery cart with a 500 Newton force along 7 meter side aisle. How much work is done in pushing the cart from one end to the aisle to the another? Again, to calculate for the value of work, so first, let's get all the given value on our sample problem. Force is equals to 500 Newton, displacement is equals to 7 meters, and again, the value of our work is the missing value. And now, after we get all the given value, let's proceed with the correct formula. So the correct formula for the value of work is W is equals to F, or W is equals to force multiplied by displacement. After we get the correct formula, let's now proceed with the substitution of our given value. Work is equals to 500 Newton multiplied by the 7 meters. That is equivalent to 3,500 Newton meter, or work is equals to 3,500 joules. Very good. Now, to summarize our discussion for today, work is done when a force is applied to an object through a distance. And for your exercise or for your homework, what you need to do is to answer this 3 sample formula or sample problem. Number 1, how much work does an elephant do while moving a circus wagon 20 meters with a pulling force of 200 Newton? Number 2, how much work is done when a force of 33 Newton pulls a wagon in 30 meters? And number 3, how much work is required to pull a lead 5 meters if you use 60 Newton of force? Again, so that would be your assignment. And again, so thank you for listening and hoping you learned something for this lesson. And always remember, stay curious on our subject. That's all for today. Thank you and see you again for our next lesson here on My Science Class.